Welcome to the second video of 6.5 simplifying radicals. In this video we're going to focus on multiplying radicals and then adding and subtracting. So go ahead and continue along in your packet. This is page number 30, multiplying radicals. Example 7. Let's multiply these two radicals. We got negative 3 square root of 3 times 4 square root 15. So when you're multiplying radicals, you can multiply radicals together. The only thing is you're going to have to keep the rational parts together, and then the irrationals, the numbers underneath the radicals, keep them together. So when I multiply, I'm going to take what's outside, those are going to be multiplied together, and then what's inside, those can be multiplied together. Okay? So let's see what that looks like. Negative 3 times 4, that's going to be negative 12. And then what's underneath the radical? We've got 3 times 15. 3 times 15 is 45. Okay, so that's multiplying them together, but since we just learned how to simplify radicals, we need to check to see if there's anything that simplifies inside the radical. So we have square root of 45. If I think of the perfect squares, 9's a perfect square, and it is a factor of 45. So this should be able to reduce a little bit. Square root of 45 is the same thing as the square root of 9 times the square root of 5. Square root of 9 is 3. So this is really 3 radical 5. Now there's a number outside already, so this number, this 3 that we're pulling out, is going to have to multiply by what's already out there, which is a negative 12. So negative 12 times 3 is going to be negative 36. And then I'm going to have a 5 still underneath the radical. Alright, so negative 36 radical 5. That's what that simplifies down to. Let's try another one. So number 8. In example 8, we've got the square root of 6 times, and we see this parentheses, 2 minus 3 radical 3. So we can distribute this to both terms. We can multiply it to the 2, but we just need to remember whatever's underneath the radical stays there. Whatever's outside the radical has to stay outside. So when I do 2 times radical 6, it's just 2 radical 6. I can't multiply the 2 and 6 together because they're not within the same section. The 2 is the rational part, and then the radical 6 is the irrational part. All right. So let's go ahead and distribute the radical 6 to the next term. So radical 6 times this 3 radical 3. So the 3 is going to stay out. And then radical 6 times radical 3 is going to give me radical 18. And then 18 does go down further. This is a problem from the first page. So 18 is the same thing as 9 times 2, which is 3 radical 2. And we already have this negative 3 out here. So I'm going to have to do negative 3 times 3, which is negative 9 radical 2. Okay? And that's as far as we can go with this problem. Radical 6 doesn't go any further. All right, example 9. So we see here it's a binomial times a binomial. So when I distribute, I am going to have to distribute both terms. So I've got 5 times 2 and then 5 times negative 3 radical 3. That's 10 minus 15 radical 3. Switch to the next term. 2 radical 3 times 2 is 4 radical 3. And then 2 radical 3 times negative 3 radical 3. 2 times 3 is 6. And then radical 3 times radical 3 is radical 9. Now that is going to simplify further, and you could have kept doing it within the problem, but I just wanted to split it up to not confuse anyone. But this radical 9 is the same thing as a 3, right? So I'm going to simplify this to 10. And then these two terms, do you see how they have the same radical? you can add those together, which is what we're going to be doing on the next page, I believe. But you can add radicals that have the same radical together, just like a variable. Okay, so think of it like a variable. Negative 15 and 4 would make negative 11, and you still have your radical 3. So it's negative 11 radical 3, and then over here we had negative 6 times 3, so that's negative 18. And then go ahead and put your like terms together. So 10 and negative 18 is negative 8. So negative 8 minus 11 radical 3. And then that's as far as we can go with that problem. All right, pause the video, give number 10 a try, and then resume when you're ready. Okay, hopefully you've given it a try. Number 10, negative 2 times negative 2 is 4. Negative 2 times negative 7 radical 2 is 14 radical 2. Next term, 7 radical 2 times negative 2 is negative 14 radical 2. And then 7 radical 2 times negative 7 radical 2 is negative 49. Radical 2 times radical 2 is radical 4, but we know that that's the same thing as 2, so I'm just going to put times 2. These middle terms, they're going to eliminate each other. 14 radical 2 and negative 14 radical 2 can cancel. So I have 4. And then negative 49 times 2 is negative 98. 4 minus 98 is negative 94. The reason why this one simplifies so far is because these two are conjugates, and that's something that we've learned in the past, and we will be using conjugates here in the next video. Alright, so let's move to the next page. Alright, so we are on the next page, and now we're adding and subtracting radicals. So we kind of did that already in that last example on number 9. Let's just get some more practice. So like I said, you can act like the radicals are variables kind of when you're trying to combine them. So they have the same properties as if you were combining variables together. So let's take a look at number 11, square root of 75 minus radical 3. So at this time we cannot put those together. But square root of 75, I believe, is something that can be simplified. So let's see if we can do that. 75 is the same thing as 25 times 3. 25 is a perfect square, so I can pull out a 5. So I got 5 radical 3. So that's what 75 is. Square root of 75 is 5 radical 3. And we still have our minus radical 3 from the back end here. So we got 5 radical 3 minus 1 radical 3. Well, that's 4 radical 3. So you see how we would just subtract those like they were variables. 4 radical 3. All right, let's move on to number 12. Okay, same thing. Let's see if we can simplify these radicals first before we try to combine anything. 20 is the same thing as radical 4 times 5. And 4 is a perfect square. I've got a 3 out in front of there, don't forget that. So I could pull out a 2 from the 4. Square root of 4 is 2. So when I pull it out, that's going to be 6, because don't forget, you multiply when you pull it out. So 6 radical 5 is this first term. Okay, let's move to the next term. 45 is the same thing as 9 times 5. What's the square root of 9? Well, that's 3. So let's pull out a 3. And don't forget about the 5 that's still underneath. And then 80. Okay, so we've got 80 is divisible by 16. Square root of 16 is 4. Okay, 80 is 16 times 5, and the square root of 16 is 4. So I can pull out a 4, but don't forget about this 4 that's already out here, right? So I'm going to have to multiply those two 4s together, and I still have this 5 underneath. So 4 times 4 is going to give me 16 radical 5. I've simplified each one individually, so I looked at each each individual radical and just simplify them. And then now I'm ready to combine like terms or combine the like variables if I can. All of these are like variables because they're all radical 5s. So 6 minus 3 is 3, and then 3 plus 16 is 19. So this is 19 radical 5. Alright, let's move on to the last one here. Number 13. Let's see if you can do this one. So pause the video, give it a try first, and then resume when you're ready. Okay, so the first thing I'm going to do is try to simplify those radicals if I can. 2 is a prime number, it doesn't simplify, and then radical 6 isn't going to simplify, and this radical 6 isn't going to simplify. So nothing simplifies, but the thing I can do is combine these two because they're both radical 6s. So I have 6 radical 2 from this first term, and then these two terms can be put together. 1 radical 6 minus 3 radical 6 would be negative 2 radical 6. Alright, and since these are different radicals, this is radical 2 and this is radical 6, this can't be simplified any further. Alright, so in this video we talked about multiplying and then adding and subtracting. In the next video we're going to talk about rationalizing the denominator and dividing. Hopefully you found this video helpful, and go ahead and move on to the next one.